Hello everyone and welcome again. In today's video we'll start programming our PIC microcontrollers using MPLAB X, but just before that let's have a look at the schematics that we're gonna be using. So this is our aim, to set the LED on or off permanently using the PIC microcontroller unit. So our program will not be toggling the LED, but we're just gonna set the pin output to either high or low permanently. Okay, so let's start MPLAB X. And now when the program starts, we should see if you've got any PIC kit programmers connected. I've got my PIC kit for that I'll be using. Okay, got some updates. Now to start the new project we need to click on this yellow file. Now we're using the standalone project. Click next. We'll be talking about 3 families in this video series: baseline, mid-range and advanced. We start with the baseline and our device will be 10F200. I'm going to be using PIC kit 4. I'm going to click next. I'm not going to be using that, so I'll click next. And our compiler, you can see more compilers if you've got more installed, but I've got XC8 and that's what I'm going to be using. Click next. So my project name is going to be 10F200, so that I know it's going to be a main project and I'm happy with the project location, so I click finish. Right, now what we see the dashboard, which is very useful. We'll be talking about this later, but it's good to familiarize yourself what's in there. What is it telling us? If for some reason you don't have a dashboard, you don't see it, you can bring it by clicking on Window, Dashboard. Lovely. So in our project we see some folders, most of them are empty. We're interested in the source file folder. Now for this one we need to create a new file, new main.c. Now this is a main file, so I'm gonna call this one 10F200 and I'm gonna call it main. I'm not gonna use a space underscore, as the compiler sometimes gives us a warning that the special signs might be interpreted differently. So I'm happy with the name and location. Click finish. Okay, now it's there. Okay, that's funny, so I'm gonna just bring it back in here. Come on, jump in there. Okay, lovely. So this is our main file. In here we see that they started the main section for us and some information about the file. It's good to keep some information there. Okay, so to start with our PIC microcontroller, what we need to do is go to production and set configuration bits. That's the first thing we need to do. Our PIC is very small device, very small yet powerful, and we've got very little options in here to use. So watchdog timer, I'm gonna switch this off, and code protection I'm gonna keep off, and master clear enable I'm gonna keep it on for a moment. However, what it says there is we losing the GP3, one of the ports, one of the pins on the port, sorry, for master clear reset function. Okay, we're gonna use it. We'll switch it off later on. We'll see what happens. We're gonna generate the code to the output. Okay, now we have to copy all this and we have to paste it just underneath that first comments. Okay, so we're doubling up this includes, so I'm gonna delete that. Now what we can see, we've got our comments. The comments between this and that symbol, they are multi-line comments, so all the grayed area are not going to be interpreted by the compiler. // is a single line comment that we can use. Okay, so these are our pragma configuration bits and we're going to leave it there. This is our main section. So in our main section, I'm just going to pause it for a second. I'm going to type in some more details and I'm going to come back to you. We're going to talk about them. Okay, so I've typed in some more information. So basically we'll be coding using binary and hexadecimal system. The prefix is 0B for binary and hexadecimal is 0x. We're talking about 1 bit, so that this is a representation of a 1 bit. 4 bits is a nibble, 8 bits is a byte, and 16 bits is a word. Okay, most significant bit is on the leftmost position, rightmost position is the least significant bit, and this is about the value that they carry. So that's how we call them. Now what does it mean? Again, to set the pin high, which means that we're looking at about 5 volts, roughly the supply voltage, and setting the pin low is clearing it from any voltage there, so we're looking for a 0 volt. Now before we can start with setting the pins high or low, we need to set the TRIS register, which means we have to give it a direction to each individual pin. Very useful now is going to be instruction, actually the data sheet for our PIC microcontroller. I've got it here, you can download it for free from Microchip website. So usually they carry a few devices on it. We've got here our one, 10F200. So what are we interested in here is PIC 10F200. We got 4 input output pins, 3 individual direction control, and 1 input only pin, so which means that we cannot drive anything out of it. It only accepts the information, and we're gonna check which one is later. So this is our symbol of our PIC microcontroller. Let me just zoom it in a little bit. So these are our GPIOs, the pins that we're going to be interested in. So this is one of them. 1, we got 2, 3, and 4. So their names are GP0, GP1, GP2, and GP3. So these are the ones that we can be using for our programming. This is supply voltage to the microcontroller, as we spoke before, not used. And now let's zoom out. Okay, so let's go to the section input output ports, and in here we got our TRIS register, we got input output GPIOs. So let's start with the TRIS register, which is the direction of the port. So now the name of our register that we have to control is this one, TRIS GPIO. So we're gonna be targeting this name. Now it's got it is a 8 bits long register, however only 4 lower bits are used, and these are controlled all in once. So let's start typing in. Let me just bring this one a little bit smaller, and we've got our data sheet next to it. Okay, so let's make this one a little bit smaller. There. Now we're gonna delete return. We're not returning. Great, a bit more space there. Let's start typing, and we're typing the name exactly as it appears on the data sheet, TRIS and GPIO. Okay, now if you notice, this is it. In the background we've got the XCH, our compiler, working for us, and it's checking constantly if we type in the data correctly. If there is something that is not going to be good, then compiler is telling us immediately. So GPIO, as we said, is an 8 bits register, so 4 upper bits we're not going to be using. Let's use the binary system. 1, 2, 3, 4 upper ones are 0. Now to set the pin either output or input, we addressing it with 0 or 1. 0 is an output, 1 is an input. As we want to drive our LED, it's going to be an output. 1, 2, 3, 4. So that's these 4 bits are going to be output. We end in every line of command with a semicolon. Great. So we got our direction port done. Now let's go to the pins themselves. GPIO, as we've seen, we've got GP0, 1, 2, 3. Again, This is the register, 8-bit register. 4 upper bits are unused. 4 lower bits, we can address them, and let's do it now. So again, the name exactly as it appears on the datasheet. GPIO is equal to 1, 2, 3, 4. Yep. And then our bits, we want them output. So we want 1, as we want a 5-volt, roughly 5-volt to appear there. 1, 2, 3, 4. We're going to talk about what's happening there in a moment. Now, if I click enter, let's see what's going to happen. Okay, everything okay for a moment. So, looks like our program is done. This are the curly brackets, so all the main code has to be contained within those curly brackets. Now, looks like the program is done. Let me build it. So we're building it using this hammer. So build means create the program and test it, debug it. So as I do that, we already see some information there. We can use this field to correct our errors. So what is it telling us? We forgot the semicolon at the end. Okay, nice. Next, this one, warning, implicit information, integer to unsigned character values. So what's happening there is, I don't know if you've noticed, I forgot to put 0B for binary. So now the code should be alright. Let's try to build it. Did I click it? There, I didn't click it. Now it's successful. Great. We've got our dashboard telling us how much space we're taking for our code. So now what we should have is our ports direction is all to output. All of our bits are set to high, so they're giving us the voltage. We're going to be sourcing some current through that. Okay, now let's go to our board and let's have a look what we've got there. So this is our breadboard. We've got the PIC microcontroller already in there. I'm sourcing some power through these jumper wires. We've got our LED. Let me just move this away. So we've got our LED connected to the resistor. I'm going to just try to zoom in a little bit more. Okay, we've got our resistor. We've got our LED. So I'm going to switch on our power supply. Great. So now this is PIC 10F200. Just try to zoom in. I don't know if you can see this. If I zoom a little bit more, it might become blurry. Yes. So 10F200. Yes. Now let's zoom out. So what we're going to be looking is to program those pins, the ones that we can use, to see if the programming was successful. And we've got 5 volts there. Now to check if everything is okay in terms of this LED and the resistor, I'm just going to take this pin and I'm going to source some 5 volts straight from the power supply, which is switched on. So if I put it there and there is a 5 volts, our LED turns red. Just try to bend it a little bit this way so we see. Actually, yep, there we go. So I'm happy that the LED is working. The resistor is limiting the current. So I should get this from our pins, as we said before. I should have something on the GP0. Nope. On this one, nope. Nope. And there is something. So why there is something? Because this pin is a master clear reset, and as you remember, we set the memory clear, master clear reset to on, which means now this pin serves as a reset button for the chip, just in case if it's stuck somewhere or if we want to reset it manually. So at the moment we can't use this pin, and in our datasheet this pin was addressed as input only, so we couldn't source the power from there anyway. Now this PIC is connected to MPLAB X through my PIC kit 4 as per our connections in the previous video. Now let's go to MPLAB X. Okay, and now I'm gonna click this button, which means make program and build the program and program the device. So I'm gonna click. Now build successful. Now it's connecting to the programmer. Okay, and yes, this is the warning that is making sure that we're using 5 volts and the device is not maximum of 3.3 volts. I'm happy with that. I click OK, don't show it again. Now we've got success. Programming verify complete. So now let's go back to this data sheet. As we go up, where is the diagram? There we go. So what should we see is GP3 input only. We can't use this to switch our LED on. Now GP0, GP1 and GP2, we got our outputs and they should set our LED to on. Okay, now let's have a look. How is this happening? Okay, I've got our pin, jumper wire, so I'm using a GP0. Just bring this up. Yep, that's good. Now I'm using a GP1. Come on. In there. Yep. GP2. Nothing. And GP3 we already know. So it might seem like GP2 is not working correctly. However, this is correct, because there is another function that we have to set for this pin to be used as a output. So apart from TRIS register, we have to go to the other register to clear this and making this pin as an output. This is something that we can discuss in a different video. Please let me know if you would like to hear about this area, how to set this pin as a output, as an input output, because we can do that. So basically this is it really. That's how we do this. If you want to control your GPIOs, then you can change the values in here. Again, right, on this, as we say, this is GP0, GP1, GP1, GP2 and GP3. GP3 we know at the moment we can't use. So let's see what's gonna happen if we're gonna switch off the master clear reset function. So I'm gonna change this to off. Now we're gonna build and program the PIC microcontroller straight away. Let's see. Okay, build successful, programming verifying complete. Okay, so let's disconnect this jumper wire from our PIC kit. Let me just put it there. Okay, so again let's check with this LED jumper. GP0, have we got still 1? Yes. GP1, yep. GP2, we know about this, there are still more things to be done. And now GP3, we know this pin can be used only as an input. However, there was still weak signal before. Now it's clear because we've switched off the master clear reset on that pin, and it cannot be used as a reset anymore. So this pin is now input only, it's waiting for the information. Just the last thing before we go is we've got the function. Let's go back to the zoom out. to our ports. Now the table, what is it telling us is our TRIS register is a one continuity. However, we've got the separate bits for our pins. So GPIOs, if we want, we can set the whole port in one go, or if you like, we can just go with the single bits and program them one by one. Single bits names, they're there. So if I want my GP0 to be 0, I don't want any voltage there, I can say that is equal to 0, done. Now I would like my GP1 still to output the voltage, or be high, sorry, I should be saying to be high. Then I'm gonna set it to 1. Now let's build and program this up. Let's connect this pin back again to master clear. Reset. Okay. Now build and program, build successful. So now what I'm expecting to see is on the GP0, according to our new program, there should be nothing. Yes. GP1 still should be high. There we go. So that's what we can do. Later on in the next videos we'll have a look at the bigger PICs. They're gonna go bigger and bigger. Instructions will be slightly different, and we're gonna start using mix, binary and hexadecimal commands just so we can practice. Okay, thank you very much for now. Thank you for watching, and please join me next time. Bye.